Hi, welcome back to my channel pibyme Maths. This is Vasudevan. Here we are solving May-June 2022 Pure Math 3 paper. In part 1 of this video, we have covered question number 1 to 5. Let's look at question number 6. We have a figure given. The function f is defined by this. Show that the first derivative of f is this. We are going to differentiate it by applying the product rule. So I'm going to take this as u 5 times x square minus 2. So when I differentiate it, 5 times 2x is 10x. And I take this as v and I apply chain rule to differentiate it. We'll get half 4x plus 9 to the power half minus 1, which is minus half, times when you differentiate 4x plus 9, it's 4. So it's basically half times 4 is 2 times 4x plus 9 to the power minus half. So we can straight away write f dash of x is equal to the product rule. So u v dash is this, u v dash. So 5 times x square minus 2 times 2 times 4x plus 9 to the power minus half plus vu dash 10x times 4x plus 9 to the power positive half. Now I have put the last step here. They want the answer in this format. So what I'm going to do, I'm going to take 4x. Okay, we are going to take out the common factor now. We have 5 times 2 here, 10. We have 10 here, so we can take out 10. And then I'm going to take out 4x plus 9 to the power minus half as a common factor. So in the first term, if you take out 10 and 4x minus 9 power minus half, you are left with x square minus 2 in the first term, plus in the second term, this is a second term, you have taken out 10, so you have x, you have taken out 4x plus 9 to the power minus half, so you will have 4x plus 9 to the power 1 actually, because if you multiply these two, you will get power positive half, right? So when you expand it, I'm going to write it as 10 times x square minus 2 plus 4x square plus 9x, and I put this 4x plus 9 to the power minus half in the denominator as positive half. We got the answer already. 10 times 4x square plus x square, 5x square plus 9x minus 2 divided by 4x plus 9 to the power half. This looks like this, right? That's all. Part B, hence find the values of x for which f dash of x is 0. We are going to put f dash of x we got from part A, 5x square plus 9x minus 2 divided by this is equal to 0. So you bring the denominator here and divide by 10. So you are going to get 5x square plus 9x minus 2 is 0, which is a quadratic function. Let's solve the quadratic. 5, 9 minus 2. 1 over 5 minus 2. X is equal to minus 2. X is equal to 1 over 5. You can write one more step here. X plus 2 times 5x minus 1 is 0. In part C, figure 3 shows a sketch of the curve with the equation this. The curve has a local maximum at P. As you can see from the figure, it has a maximum point at P, where x will be a negative number, right? Okay. Now back to the question, find the exact coordinates of P. So we have two x coordinates, minus 2 and 1 over 5. You need to use minus 2, not 1 over 5. Take the function f of x is equal to 5 times x square minus 2 and then 4x plus 9 power half, 4x plus 9 to the power half, sub in the x coordinate to find the y coordinate. 5 times minus 2 square minus 2, 4 times minus 2 plus 9 to the power half. This is basically 1 because 9 minus 8 is 1, 1 power half is 1. 5 times 4 minus 2 is just 2, 10. Therefore, P of minus 2, 10. Let's look at the next part. The function g is defined by g of x is equal to 2f of x plus 4. From minus 9 over 4 to 0, find the range of g. To explain this part, dear, here put the figure and the function here. As you can see, the function is defined over this domain, minus greater than or equal to minus 9 over 4. That means this is minus 9 over 4. And the function is defined over this, right? We need to know this value, the y-intercept. So when you replace x by 0 into the function, f of 0 is, this is 0, this is 0, 5 times minus 2 times 9 power half, you get negative 30. Okay? I'll tell you why we need the y-intercept. Why do we need this point? Okay. Let's sketch this g of x. There are two transformations involved. The first one is 2f of x, right? So the 2f of x, when you it's a stretching along y-axis, so the graph will be like this. This minus 30 becomes minus 60 now. But we are taking the graph from minus 9 over 4 to 0. Minus 9 over 4 to 0. Only here. We don't need this piece actually. We don't need this piece. We only need till here actually. That's minus 60. Now when you add 4, it's a translation upwards. So you need to move the graph upwards. So the graph is going to be something like this. Here, this point is important. It's going to be minus 60 plus 4 minus 56. And the point P, when you apply the transformation, the point P was minus 210. That's the point on f of x. When you apply 2f of x, the point is going to be P of minus 220. When you apply 2f of x plus 4, that's going to be minus 224. This point is P of minus 2, 24. So the y coordinate is 24. So the range is this. From 56 to this, right? But how do you show the working? You have to show 2 times minus 30 plus 4 is equal to minus 56, and then 2 times the y coordinate of this point. 2 times 10 plus 4 is 24. Therefore the range is minus 56 is less than or equal to g is less than or equal to 24. That's all. That's a 3-mark question, and these are all the working for this question. Let's look at the next question. Question number 7. Show that this equation can be written in this form. So we are going to take the whole equation and we try to rewrite the equation in this format. So what I'm going to do, I'm going to write it as 2 sine theta. We know cosecant square theta minus cot square theta, the theta can be anything, is equal to 1, right? So when you rearrange, you will get cosecant square theta minus 1 is cot square theta. So I'm going to replace this with cosecant square 2 theta minus 1. When you multiply by 3, it's going to be 3 cosecant square 2 theta minus 3 minus 7 is equal to 13 over cos theta, right? We need to have 2 theta everywhere. You cannot have just theta. So we are going to try to change these 2 into 2 theta. How do we do that? Push the 2 sine theta to the other side. So you're going to get 3 cosecant square 2 theta minus 10 is 13 over 2 sine theta cos theta. We know sine 2 theta is 2 sine theta cos theta, right? So sub in sine 2 theta here. 13 over sine 2 theta is 13 cosecant 2 theta. 1 over sine is cosecant, right? 3 cosecant square 2 theta minus 10. Put this here, you got the answer already. 3 cosecant square 2 theta minus 13 cosecant 2 theta minus 10 is 0. That's all. That's what they want us to prove here, right? Let's move on to double I. Hence solve from 0 to pi over 2 this original equation. We have rewritten this equation as 3 cosecant square 2 theta minus 13 cosecant 2 theta minus 10 is 0, right? So instead of solving this, we are going to solve this. It's harder trigonometric equation because you have 2 theta, so you need to multiply the limits by 2. So you're going to get 0 is less than 2 theta is less than pi, right? And then let's solve this quadratic equation. 3 minus 13 minus 10. You get 5 and 2 over 3. You'll get 5 minus 2 over 3. So you can write a step here. Cosecant 2 theta minus 5 times 3 cosecant 2 theta plus 2 is 0. Change this to a factor so you won't lose a mark. Okay. Now flip both sides. This becomes sine 2 theta is 1 over 5 and sine 2 theta is minus 3 over 2. We need to solve these 2 equations in this limit. Definitely the range of sine theta is minus 1 to 1. This is minus 1.5. So for this, no solution. So we just need to solve only one equation, right? So I'm going to take the equation separately. Sine 2 theta is 1 over 4. 0 is less than 2 theta is less than pi. We need to solve this using the method we have learned in Pure Math 2. First, find the principal value, sine inverse of 1 over 5 in radians. Sine inverse of 1 over 5. Okay. 0.201 dot dot dot. Do not round the figure. You can only round the figure at the end when you write the answer. So I'm going to store this value as a. Okay. Now we use the CASH diagram or ASTC diagram. The limit given is 0 to pi. You need to look for a quadrant where sine theta is positive. So you need to take both actually. Here it's theta, here it's pi minus theta. So 2 theta is equal to theta or pi minus theta. And then divide both by 2 and then round it to 3 significant figure. Okay. So when I divide the answer by 2, I'm getting 0.101 is the first answer, 101. And then I take the value, subtract the value from pi, I store the value as a, divided by 2, I got 1.47. That's all. 2 solutions. Question number 8. Figure 4 is a graph showing the velocity of a sprinter during a 100-meter race. Okay. This is time x-axis, y-axis is velocity. Now, the sprinter's velocity during the race v meter per second is modeled by this equation, okay, where t seconds is the time after the sprinter begins to run. According to the model, find using calculus the sprinter's maximum velocity during the race. The maximum velocity is this actually. This is the maximum velocity. That's a turning point, right? So to find the turning point, you need to differentiate it with respect to t and equate it to 0. We are going to differentiate this with respect to t. So dv over dt is equal to 0. 12 becomes 0 minus e power t minus 10 stays the same times. When you differentiate t minus 10, it's just 1 minus 12. Minus 0.75 times e power minus 0.75 is equal to 0. So 12 times 0.75 is 9. So that's positive 9. So you have 9 e power minus 0.75 t, there is a t also here, is equal to e power t minus 10. And it's a 5-mark question because we have to make t as a subject. So I'm going to bring this term here to the denominator. So I will get e power t minus 10 divided by e power minus 0.75 t is 9. Put it on top. So it's going to be e to the power t minus 10 times e to the power 0.5 t is 9. When you combine it, e power 1 plus 0.5, 1.75 t minus 10 is 9. When you remove e power, the other side becomes ln, right? So 1.75 t minus 10 is ln 9. So t is 10 plus ln 9 divided by 1.75. Plus ln 9 divided by 1.75. 6.9698, 6.9698, etc. So t is 6.97 when you round it to 3 significant figure. Nothing is mentioned in the question. Round it to 3 significant figure seconds. Okay, but this is t, right? Seconds. But what does the question says? Find the maximum velocity. They don't want you to find the time when it reaches maximum velocity. They want you to find the maximum velocity. So the t we calculated, right? We need to sub in back in here to find the velocity now. So don't use a rounded figure. Use the actual figure. Sub in into v. You will get 12 minus e to the power t minus 10 minus e power t minus 10, 12 e power 0.75 minus 0.75 times 6.96 dot. So let's store this value as a. Now 12 minus e to the power, I have stored the values a, so a minus 10 minus 12 e to the power minus 0.75 times the value. You get 11.88. 11.887 dot dot dot. When you round it to 3 significant figure, 11.9 meter per second. That's the velocity. So that's all. Don't just find t. That's like finding the x coordinate of the turning point, but they want the y coordinate, in this case the velocity, maximum velocity. So we might need the value later, so I'm going to store the value as b. Okay. Let's move on to the next part. Given that the sprinter runs 100 meters in t seconds Integral 0 to t v dt is 100. Show that t is the solution of this equation. So basically we need to integrate v. So integral 0 to t, write v here, 12 minus e power t minus 10 minus 12 e power minus 0.75 t dt is 100. When you integrate it, you're going to get 12t minus e power t minus 10 divided by the coefficient of x. Coefficient of t is 1. 12. E power minus 0.7t divided by the coefficient of t is equal to 100. Hope you understand this. So when you sub in the upper limit, basically you are going to change all the small t to capital T. So it's going to be 12t minus e power t minus 10 and then minus 12 divided by minus 0.75, that's 16, positive 16 e power minus 0.75 capital T, that's upper limit, minus. When you sub in lower limit, don't just blindly put 0, it's not 0, this becomes 0, here this becomes 0, so you will have minus e power minus 10, here this becomes 0, so e power 0 is 1, you will get plus 16, 12 over 0.75 is plus 16 is equal to 100. Hope you understand this step. From here, we need to frame this equation by making one of the t as a subject. Since it's 1 over 12, you bring the 12 here, you'll get 12t, right? That tells us most probably we are going to make this 12t as a subject. So push the rest of the terms to the other side. So you can write 12t is equal to e to the power t minus 10. You have 100 here. This minus 16 goes to the other side. You will get 116. And then minus 16 e power minus 0.75 t. I'm writing it in the same order. Plus e power t minus 10. And then this is positive, goes to the other side, minus. Therefore, t is equal to 1 over 12 times the whole thing. 0.75 t, e power t minus 10, e power minus t. That's what they want. Part C now. The iteration formula, they change the answer from previous part to a iterative formula, is used to approximate value of t. Using this iteration with t1 is 10, find t2 and the time taken by the sprinter to run the race. Okay, that means basically you need to write t2 is equal to 1 over 12 times 116 minus 16 e power minus 0.75 t, t1 which is 10. You need to show this working, otherwise you will lose more. Plus e power 10 t minus 10 which is 10 minus 10 minus e power minus 10. You will get the value of t2. So I'm going to type this in my calculator. You got to be very careful. 1 over 12 times 116 minus e to the power minus 0.75 times 10. Bring the cursor here. Plus e to the power 10 e to the power 10 minus 10 minus e to the power minus 10. Be rounded to 4 decimal places. So let's type everything in the calculator carefully. 1 over 12 times 116 minus 16 e to the power minus 0.75 times 10 plus e to the power 10 minus 10 minus e to the power minus 10 and close the bracket. They want the answer to 4 decimal place, 749.7493. 9.7493. That's one answer for I. For double I, we are going to sub in the value of T2 back in the place where we have T here and calculate again. We need to continuously do the iteration till we get the same answer, till we get the same 4 decimal places. So in order to do that, what I'm going to do, I'm going to move my cursor to this 10 is the value of T1, right? I'm going to delete it, change it to answer, so it will take the new answer as an input here. This 10 also supposed to be T. So when I press equal, I get 7306, 7294, 7293, 7293. It got stuck at 7293. So the answer is 9.7293. That's all. Question number 9. We have a figure 5 given here. Figure 5 shows the curve with this equation. The point M shown in figure 5 is a minimum point. This is a minimum point, okay? So if they ask you to find the coordinates, you need to differentiate the function, equate it to 0. Show that the x coordinate of the M is, yes, they don't want you to find the x coordinate, they want you to frame this equation. So you need to differentiate it, equate it to 0. So I'm going to take the numerator as u, 1 plus 2 cos x, denominator as v. You need to show all this working, okay? U dash is minus 2 sin x, 1 becomes 0, v dash is just cos x. So the quotient rule is vu dash minus uv dash over v square. So you need to write dy over dx is equal to 0. So vu dash, which is minus 2 sin x times 1 plus sin x, minus uv dash cos x times 1 plus 2 cos x, everything divided by v square is equal to 0. So what I'm going to do, I'm going to move the denominator here now and open the bracket here. So I will get minus 2 sin x minus 2 sin square x. Here open the bracket. Minus cos x minus 2 cos square x is 0. From these two terms, if you take minus 2 as a common factor out, you will get minus 2 times, from these two terms, you get minus 2 times sin square plus cos square, which is 1, right? So minus 2 sin x minus cos x minus 2 is 0, because when you combine them, you will get minus 2 times sin square plus cos square. Sin square plus cos square is 1, so it's just minus 2. So I think this is the equation they want us to frame, right? Yeah. So just push these two terms to the other side. So you got the equation 2 sin x plus cos x is equal to minus 2. That's the required equation. Hence, find the x coordinate of n. So basically, they want you to solve the equation we just framed. 2 sin x plus cos x. 2 sin x plus cos x is equal to minus 2. To solve this equation, you need to remember this. Let's say instead of minus 2, you have 0. That's very easy. Divide throughout by cos x. You will get 2 tan x plus 1 is 0. Tan x is minus half. And then just solve it within the given limit. The limit is minus pi over 2 to 3 pi over 2. The limit is minus pi over 2 to 3 pi over 2. If it is 0, but in this case it's not 0, so if you divide throughout by cos theta, cos x, you are going to get 2 tan x plus 1 is minus 2 over cos x, and it's very hard to get rid of this cos x. So this method will not work. So when you have a number on the other side, you need to convert this into r sine x plus alpha or r cos x minus alpha. Why x minus alpha? Because you have a plus here. In cos of a minus b, you will have plus in the middle, right? So I'm going to take the first one. So I'm going to equate this to r sine of x plus alpha is equal to 2 sine x plus cos x, and find r and alpha first. So when you expand it, sine of a plus b is sine a cos b multiplied throughout by r. Cos a sine b is 2 sine x plus cos x. Compare the coefficient of sine x on both sides of the equation. You have r cos alpha is equal to 2. Compare the coefficient of cos x both sides. You have r sine alpha is equal to 1. So when you square and add them, r square cos square plus r square sine square, cos square plus sine square is 1, right? Is 2 square plus 1 square, which is 5. That gives us r is equal to square root of 5. If you divide them, r sine alpha over r cos alpha is 1 over 2, or r can be cancelled, tan alpha is 1 over 2. So alpha is tan inverse of 1 over 2. Okay, 0.463 dot dot dot. I'm gonna immediately store the value as a, because we will round the figure only at the end. So I'll just put a little reference here. So you can write this whole thing as r sine x plus alpha, or sine x plus alpha. Okay, so we are going to use this here to solve the equation now. So what I'm going to do, instead of this, I'm going to write square root of 5 sine x plus 0.463 dot 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 is equal to minus 2, and we have the limit here. First, let's find the principal value. When you find the principal value, ignore the negative sign. 2 over square root of 5. Sine inverse of 2 over square root of 5. And immediately store the values b. 1.107. 1.107 dot dot dot. X plus 0.463 dot dot. Now let's use the ASTC diagram. And I split the limits into minus pi over 2 to 0 first. That's this limit. We need to find the quadrant where sine theta is negative, right? Now we need to consider the negative sign. So this is negative, where the angle is minus theta. So x plus 0.463 dot 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 is negative theta. Theta is a principal value, comma. Let me take the other limit, 0 to positive 3 pi over 2. 0 to positive 3 pi over 2. 3 quadrants. It covers 3 quadrants where sine theta will be negative only in here, which is pi plus theta. So pi plus the principal value. So we need to subtract minus 0.463 dot 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 from these two. Get the answer. So the first one is minus 10, so that's basically minus b. I stored the value as b, minus 0.463 dot dot dot. I stored the value as a. So I'm getting minus pi over 2 here. Okay, so the second value now, pi plus, I stored the value as b, minus 0.463, that's a. We are getting 3 point. They want the answer to be rounded to 3 significant figure. So 3.79, that's the second answer. You cannot add minus pi over 2 because there is no equal sign here. Therefore, x is equal to 3.79. That's all.